In the late 1970s, Kansas City was preparing to unveil one of the most ambitious hotel projects in the United States. The Hyatt Regency Kansas City was designed to be more than just a hotel. It was intended to be a symbol of luxury, innovation, and modern architecture. At the center of the building stood a massive atrium that immediately captured attention. The towering interior space featured glass elevators, elegant walkways suspended high above the floor, and a design unlike anything many visitors had ever seen before. Guests were amazed. Architects praised the project, and the hotel quickly became one of the most recognizable buildings in the city. The suspended walkways crossing the atrium became its signature feature. They appeared light, elegant, and almost floating in midair. Few people ever questioned whether they were safe. After all, the structure had been designed by professional engineers, reviewed by contractors, and approved through the normal construction process. To visitors, the walkways represented modern engineering at its finest. But hidden behind the polished surfaces and elegant appearance was a design flaw that nobody fully recognized. A flaw that would remain unnoticed until it was far too late. For months, thousands of people walked across those suspended bridges without incident. Weddings were held. Business events were hosted. Families gathered. The hotel became a popular destination throughout the region. Everything appeared perfectly normal. Yet one small change during the construction process had already set the stage for disaster. A decision that seemed minor at the time would eventually become one of the deadliest engineering mistakes in American history. Few people could have imagined that one of the hotel's most celebrated features would eventually become the source of a national tragedy. Few people ever questioned whether they were safe. After all, the structure had been designed by professional engineers, reviewed by contractors, and approved through the normal construction process. To visitors, the walkways represented modern engineering at its finest. But hidden behind the polished surfaces and elegant appearance was a design flaw that nobody fully recognized. A flaw that would remain unnoticed until it was far too late. For months, thousands of people walked across those suspended bridges without incident. Weddings were held. Business events were hosted. Families gathered. The hotel became a popular destination throughout the region. Everything appeared perfectly normal. Yet one small change during the construction process had already set the stage for disaster. A decision that seemed minor at the time would eventually become one of the deadliest engineering mistakes in American history. On the evening of the 17th of July 1981, the Hyatt Regency Hotel was alive with energy. Inside the massive atrium, hundreds of people gathered for a popular social event known as the Friday Night Tea Dance. Music echoed throughout the building. Couples danced across the floor. Friends laughed together. Families enjoyed the atmosphere. For many people, it seemed like a perfect summer evening. The Hyatt Regency had quickly become one of the most recognizable destinations in Kansas City, and events like this regularly attracted large crowds. That night was no exception. More than 1,600 people were inside the hotel. Some stood on the atrium floor watching the dancers. Others gathered on the suspended walkways above, enjoying a clear view of the event below. The elevated bridges had become one of the building's most famous architectural features. Guests often stopped there to talk, observe the crowd, and take in the impressive view. Everything appeared completely normal. The walkways had been used countless times before. No alarms were sounding. No visible damage could be seen. There was no indication that anything was about to go wrong. Then, shortly after 7 o'clock in the evening, witnesses began hearing unusual sounds. At first, they were subtle. Small noises that could easily be ignored in a crowded hotel filled with music and conversation. Most people paid little attention, but within moments, those sounds became louder. A sharp crack echoed through the atrium. Heads turned. People looked upward. Confusion spread through the crowd, and then the unimaginable happened. One of the suspended walkways suddenly failed. Almost instantly, another walkway connected above it collapsed as well. Thousands of pounds of steel, concrete, and people crashed downward into the packed atrium below. The collapse happened in seconds. There was almost no time to react. People standing on the bridges were thrown into the air. Guests below were buried beneath massive sections of the structure. The sound was deafening. Dust filled the atrium. Screams erupted from every direction. What had begun as a joyful evening had transformed into a nightmare. Within moments, the hotel was plunged into chaos. Emergency calls flooded local dispatch centers. Hotel staff rushed toward the destruction. and survivors desperately searched for friends and family among the wreckage. No one yet understood what had caused the collapse, but everyone knew they were witnessing one of the worst disasters in the city's history. Screams erupted from every direction. What had begun as a joyful evening had transformed into a nightmare. Within moments, the hotel was plunged into chaos. Emergency calls flooded local dispatch centers. Hotel staff rushed toward the destruction, and survivors desperately searched for friends and family among the wreckage. No one yet understood what had caused the collapse, but everyone knew they were witnessing one of the worst disasters in the cities. After the dust settled and rescue operations began, investigators were faced with a critical question. How could two massive walkways inside a modern hotel suddenly collapse without warning? At first, many people believed the crowd must have been too heavy. Others suspected poor construction materials or hidden damage. But the truth turned out to be far more shocking. The walkways had not collapsed because of an unusually large crowd. They failed because of a design change made long before the hotel ever opened. To understand what happened, investigators carefully examined the original engineering drawings. The walkways were designed to hang from steel rods connected to the roof structure above. In the original design, long continuous rods would pass through multiple levels of walkways, allowing the load to be distributed throughout the system. On paper, the design appeared capable of supporting the expected weight. However, during construction, a modification was proposed. Instead of using one continuous rod, the contractor suggested splitting the rod into two separate sections. The change seemed simple. It would make fabrication easier, installation would be faster. And to many people involved, the new arrangement appeared nearly identical to the original design. But structurally, it was not identical at all. The modification completely changed how forces moved through the connections. In the revised design, the upper walkway was no longer supporting only itself. It was now supporting the weight of the lower walkway as well. That meant critical connection points were carrying significantly more load than engineers had originally intended. In some locations, the force on the steel box beam connections nearly doubled. The danger was hidden. From the outside, the walkways looked perfectly normal. Guests could not see the overstressed connections. Even many people working on the project did not fully understand the consequences of the change. For months, the structure remained standing. Thousands of people crossed the walkways. Nothing appeared wrong. Every successful day reinforced the belief that the system was safe, but the weakness never disappeared. It remained buried inside the steel connections, waiting for the right conditions. On the night of July 17th, the walkways were carrying ordinary loads. Nothing extraordinary was happening. Yet the hidden flaw had already reduced the structure's safety margin to a dangerous level. When the connections finally failed, the collapse was sudden and catastrophic. Investigators later concluded that the revised design simply could not support the loads it experienced. The failure was not caused by a natural disaster. It was not caused by sabotage. And it was not caused by unusual crowd behavior. It was the result of a preventable engineering mistake. A mistake hidden inside a seemingly minor design modification. One overlooked decision, one critical detail, and one of the deadliest structural failures in American history. The most dangerous flaws are frequently the ones nobody can see. By the time the weakness finally revealed itself, there was no opportunity to stop the disaster. The structure had already reached its limit, and when the connections failed, the collapse happened almost instantly. From the outside, the walkways looked perfectly normal. Guests could not see the overstressed connections. Even many people working on the project did not fully understand the consequences of the change. For months, the structure remained standing. Thousands of people crossed the walkways. Nothing appeared wrong. Every successful day reinforced the belief that the system was safe. But the weakness never disappeared. It remained buried inside the steel connections, waiting for the right conditions. On the night of July 17th, the walkways were carrying ordinary loads. Nothing extraordinary was happening. Yet the hidden flaw had already reduced the structure's safety margin to a dangerous level. When the connections finally failed, the collapse was sudden and catastrophic. Investigators later concluded that the revised design simply could not support the loads it experienced. The failure was not caused by a natural disaster. It was not caused by sabotage. And it was not caused by unusual crowd behavior. It was the result of a preventable engineering mistake. A mistake hidden inside a seemingly minor design modification. One overlooked decision, one critical detail, and one of the deadliest structural failures in American history. When the walkways finally failed, the collapse happened with terrifying speed. Witnesses described hearing a loud cracking sound echo through the atrium. Within seconds, two suspended walkways crashed downward into the crowded lobby below. Thousands of pounds of steel, concrete, and debris fell onto hundreds of people gathered beneath them. The impact was devastating. People standing on the bridges were thrown into the air. Others below were crushed beneath the collapsing structure. The noise was deafening. Dust filled the atrium, and confusion spread instantly throughout the hotel. For a few moments, many survivors struggled to understand what had happened. Some believed there had been an explosion. Others thought part of the building had collapsed. The scene quickly turned into chaos. Screams echoed through the atrium. People searched desperately for friends and family members. Many victims were trapped beneath layers of steel and concrete. Some remained pinned for hours. Emergency calls flooded local dispatch centers. Police officers, firefighters, paramedics, and rescue teams rushed to the hotel. Within minutes, one of the largest rescue operations in Kansas City's history was underway. Rescuers faced enormous challenges. The collapsed walkways created unstable piles of debris. Heavy components threatened to shift at any moment. Every movement carried additional risk. Teams worked carefully, searching for survivors trapped beneath the wreckage. Medical personnel established emergency treatment areas both inside and outside the hotel. Victims were transported to nearby hospitals as quickly as possible. Throughout the night, rescue workers continued digging through debris. Some survivors were pulled from the wreckage hours after the collapse. Others were not as fortunate. As the scale of the disaster became clear, the tragedy shocked the entire nation. By the time rescue operations ended, 114 people had lost their lives. More than 200 others had been injured. It remains one of the deadliest structural failures in American history. And while rescuers fought to save lives, investigators were already beginning to ask a difficult question. How could a disaster of this magnitude have happened inside a modern building? Throughout the night, families gathered outside the hotel waiting for news. Many had no idea whether their loved ones had survived. Hospitals across the city received a steady flow of injured victims. Doctors and nurses worked continuously to handle the emergency. For those inside the atrium, the situation was heartbreaking. Some survivors could hear voices beneath the debris, but were unable to reach the trapped victims immediately. Others spent hours waiting for help to arrive. As dawn approached, the true scale of the disaster became impossible to ignore. What had begun as an ordinary social event had become one of the worst structural tragedies in American history. Some survivors were pulled from the wreckage hours after the collapse. Others were not as fortunate. As the scale of the disaster became clear, the tragedy shocked the entire nation. By the time rescue operations ended, 114 people had lost their lives. More than 200 others had been injured. It remains one of the deadliest structural failures in American history. And while rescuers fought to save lives, investigators were already beginning to ask a difficult question. How could a disaster of this magnitude have happened inside a modern building? In the weeks following the disaster, one of the largest engineering investigations in American history began. Government agencies, structural engineers, industry experts, and independent investigators all worked to determine exactly what had happened. The collapse had killed 114 people and injured more than 200 others. The public demanded answers. Investigators carefully examined the wreckage. Steel components were removed and analyzed. Construction records were reviewed. Engineering calculations were checked and rechecked. Every detail of the project came under intense scrutiny. As evidence accumulated, a clear picture began to emerge. The disaster was not caused by poor weather. It was not caused by overcrowding. And it was not caused by a failure of construction materials. Instead, investigators traced the collapse to a critical design flaw within the suspended walkway system. The original design had relied on continuous hanger rods extending through multiple levels. However, a modification introduced during construction changed the way loads were transferred through the structure. At first glance, the revised design appeared harmless, but detailed analysis revealed a serious problem. The new arrangement significantly increased the forces acting on key connection points. Those connections were never designed to support such loads. When engineers calculated the actual stresses, the results were alarming. The connections possessed only a fraction of the strength required under certain loading conditions. In effect, the structure's safety margin had been dramatically reduced. The collapse was no longer a mystery. It was the consequence of a design change that had not been fully evaluated. Investigators concluded that proper engineering review could have identified the problem before construction was completed. The findings shocked the engineering profession. A mistake that appeared small on paper had produced catastrophic consequences in the real world. The disaster became a powerful reminder that even minor design modifications must be carefully analyzed, reviewed, and approved. Because in engineering, small details can carry enormous consequences. The disaster demonstrated that even when a modification appears minor, it must still undergo the same level of technical review as the original design. Investigators emphasized that assumptions can be dangerous. Every structural change must be verified through proper calculations and independent review. The cost of overlooking a single detail had proven to be devastating. A mistake that appeared small on paper had produced catastrophic consequences in the real world. The disaster became a powerful reminder that even minor design modifications must be carefully analyzed, reviewed, and approved. Because in engineering, small details can carry enormous consequences. More than 4 decades have passed since the Hyatt Regency disaster. Yet the lessons from that night continue to influence engineers around the world. The collapse remains one of the most studied structural failures in engineering history. Universities still teach it. Professional organizations still reference it. And engineering students continue analyzing the disaster as a reminder of how small decisions can produce enormous consequences. The tragedy changed the way many projects are reviewed. Design modifications now receive greater scrutiny. Communication between engineers, contractors, and fabricators has become far more rigorous. Review procedures have improved. Quality control standards have strengthened. And the engineering profession continues learning from the mistakes revealed by the collapse. What makes the Hyatt Regency disaster so powerful is that it was entirely preventable. The victims were not facing a hurricane. They were not experiencing an earthquake, and they were not caught in a terrorist attack. They were attending a normal social event inside a modern building, a place they believed was safe. Yet a single design change altered the behavior of a critical structural connection. And that decision ultimately led to one of the deadliest engineering failures in American history. Today, the Hyatt Regency collapse serves as a reminder that engineering is about more than calculations and drawings. It is about responsibility, because behind every blueprint are real people whose lives depend on the decisions engineers make. And sometimes, the smallest detail can become the difference between success and disaster. Thank you for watching. If you enjoy engineering stories, construction failures, and